Hello everyone, class 9 chapter number 5, exercise number 5.1. First question, which of the following statements are true and which are false? Give reason for your answer. First one, only one line can pass through a single point. So this statement is false because infinitely many lines can pass through a single point in a different direction. Like this, if we consider this point, many lines can pass through this point in different direction. That's why this statement is false. So also you have to write the reason that infinitely many line can pass through a point in a different direction. Next one, there are an infinite number of line which pass through two distinct point. See here one word two distinct point is given like this. If we consider two distinct point, only one line can pass through the two distinct point. That's why this statement is false. Clear? Through two distinct points, only one line can pass. Third one, a terminated line can be produced infinitely on both the sides. This statement is true because we can extend any line on both the direction. This is the terminated line. But this arrow means that it is extended on both the sides. That's why the terminated line can be produced infinitely on both the sides. True sentence. Fourth one. If two circles are equal, then their radius are equal. Obviously, this is a true statement. If both the circles are equal, so we can say that the two circles of equal area will have the same radius from the relation area, that is area of equation pi r square. Here r is radius. If area of two circles are same, like this, let's consider first circle have radius r1 and other circle have radius r2 square. So pi cancel, r1 square equal to r2 square. That's why r1 equal to r2. So we can say that if two circles are equal, then their radius are also equal. Next one. So this statement is true. Last one. In the figure, if AB equal to PQ and PQ equal to XY, then AB equal to XY. In this question, three figures are given. AB, PQ and XY. It is given in the question that AB equal to PQ. AB and PQ both are same in length. PQ and XY also are same. So we can say that AB equal to XY. So with the help of axiom, we can say that this statement is true. True statement. Clear? So from the axiom that if two things are separately equal to a third thing, then they are equal to each other. Clear? Next question. Give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? We have to give a definition of this word. First one is parallel line. So definition of parallel line: two straight lines which have no point in common are said to be parallel to each other. Like this. Two straight line. Here two straight lines are given, and out of these two straight line there is no any common point in both the line. So we can say that both the lines are parallel to each other. Point and straight line will have to be defined first. Okay, to understand parallel line, we have to define the point and straight line. What is straight line and point? first. So as per the Euclid's text, we can say that a point is that which has no part. Point is just a dot, and a line is a breathless length, and a straight line is a line which lies evenly with points on itself. Millions of points are lines lies on this line. Clear? So this is the definition of parallel line. Perpendicular line. If one among two parallel line is turned by 90 degree, the two lines become perpendicular to each other. Let's understand by figure. Here two lines are given. Both are straight line. Now out of these two line, if we turn any one line to 90 degree, turn this line by 90 degree, like this line as it is. If we turn this line 90 degree, it will be now like this, and we have 90 degree over here now. So these lines are called perpendicular to each other. So parallel line has been defined before rotation through 90 degree needs further defining. Okay. Now rotation may be assumed as a institution, therefore cannot be used. Next. Line segment. Line segment. A line with two endpoints is a line segment. If we consider this line AB, let's consider here one CD. So a line with two endpoints. Here we have two endpoints C and D. So we can say that CD is a line segment. So we can indicate like this. This is CD is line segment, and AB is line. Line and point have to be defined before. Radius of the circle. Radius of the circle. The line segment with one end point at the center and the other at any point on the circle. Here we have one circle. Radius means what? The line segment. Radius is a line segment with one end point at the center of the circle. Let this O be the center of the circle, and other endpoint is on the circle. So OA. So we can say that here OA is the radius of the circle. Clear? Center may be defined as a point inside the circle which is at the same distance from all the points on the circle. Center, yes. If we measure the distance of this center O from any point on the circle, it will be same. Clear? So these all distance are same. Next. Square. A quadrilateral with all sides equal and all angles right angle is a square. Any quadrilateral, we know that square is all the four sides are same, all the angles are 90 degree, is called square. Quadrilateral is a figure with four sides. So figure side angle may be assumed as known. Question number 3. Consider two postulates given below. Given any two distinct points A and B, therefore exists a third point C which is between A and B. In first statement, it is given that consider two distinct points, two different points. There exists a third point C which is between A and B. Yes, always the infinitely many points lies between the 2 points. Second one, there exists at least 3 points that are not on the same line. So in second postulate, it is given that there exists at least 3 points that are not on the same line. Do this postulate contain any undefined term? Are this postulate consistent? Consistent means that cannot be changed. Do they follow from Euclid's postulate? Explain. Okay, let's start. In postulate 1, it is given that in between point A and B remain an undefined term which appeals to our geometry institution. If we consider any line, segment and two points A, B. So here points A and B are undefined. The postulates are consistent, they do not contradict each other. Yes, both the postulates are consistent because they cannot be changed. They do not contradict each other. Both of these postulates do not follow from the Euclid's postulate. However, they follow from the axioms. Both the postulates follow the axioms given by Euclid's. Let's understand. Given two distinct points, there is a unique line that pass through them. If we consider two distinct points, only one line can, unique line means only one line can pass through that point. So we can say that let AB be the straight line. This is the straight line. A, B. There are infinite number of points composing the line. Yes, infinitely many number of many points lies on this line. Choose any except two endpoints. Okay, out of these two, many points can be lies on this line. So choose any one. The point lies between A and B. So we can say that this point, let's consider D. Point D is lies on between A and B. Next, if there are only two distinct points, they can always be connected by a straight line. Yes, if you join two point, it will be a straight line. Therefore, there have to be at least 3 points for one of them not to fall on the straight line between two other two. Therefore, there have to be at least 3 points for one of them not. Yes, if we draw one line AB and if we consider one more point outside the line, clear? Next, if a point C lies between point A and B such that AC is equal to BC, then prove that AC equal to AB. Explain by drawing. Okay, to understand this, here we have to prove AC equal to 1 by 2 AB. It is not printed. Let's consider one line segment. This is line segment AB. In between one point C is given. Now it is given that AC equal to BC. This is AC, this is BC. So it is given AC equal to BC. Okay, now we have to prove that AC equal to means this small part is equal to half of full, 1/2 AB. Okay, to prove that we will use we know that equals are added to equals. Remember x equal to y, so we can write x plus 5, y plus 5. Same way, here we can write AC equal to BC is given. Now we will add AC on the both side. So AC plus AC, adding AC on both the side, BC plus AC. We can write over here equals are added to equal. Now BC plus AC. Now this is BC plus AC equal to AB. So we can write BC plus AC coincides with AB. So we, at the place of BC plus AC, we can write AB. And now AC plus AC, 2AC, and BC plus AC is AB. If we transpose these 2 on that side, it will be 1 by 2 AB. Clear? So it is, hence it is proved. Next question. In question number 4, point C is called the midpoint of the line segment AB. Prove that every line segment has one and only one midpoint. Okay. Let there be two such midpoint. Let's consider that let there be two such midpoint C and D. Then from above theorem we can write, above means theorem which is given in the question number 4, AC equal to 1 half AB. Also we can write AD, sorry, okay, for first condition we can draw like this, AB and midpoint is C1, C, and in another condition AB midpoint is D. So first condition we can write AC equal to 1 half AB, and second condition AD equal to 1 half AB. Now here right hand side for both the expression are same, so we can directly write, that's why AC equal to AD. Clear? AC equal to AD. That means that both the points C and D coincide each other. Clear? But this is possible only if D coincide with C. Therefore, C is a unique midpoint, hence proved. So we can write one sentence over here. But this is possible only if point D coincide with C. Coincides with C. C is a unique midpoint. Therefore, we can say that C is the unique midpoint. Clear? Next one. Question number 6. Question number 6. In sixth question, one figure is given. Let's draw. Figure is given like this. AD. In between here, B and C is given. Okay. In figure, AC equal to BD is given. AC, we can see that AC equal to BD is given. This part is AC, this part is BD. AC equal to BD is given, and we have to prove that AB equal to CD, and we have to prove AB equal to CD. Okay. First, what is given we can write given AC equal to BD. AC equal to BD is given. Now, and we have to prove AB equal to CD. We have to prove. So, using this diagram or a figure, we can write AC equal to AB plus BC. AC equal to AB plus BC, and BD means this part. BD equal to BC plus CD. BD equal to BC plus CD. Now it is given in the question that AC equal to BD. AC equal to BD is given in the question. So AC is AC equal to BD. This is given in the question. Now we have a value of AC. This is the value of AC. So we will put value of AC AB plus BC equal to value of BD now BC plus CD. Now AB plus BC. Now if we transpose this BC on that side, it will be minus BC. Here we have AB equal to BC plus CD. If we transpose this BC on that side, it will be minus BC. Plus BC minus BC cancel. So now we have AB equal to CD. Hence it is proved. Done. Next one. Why is axiom 5 in the list of Euclid's axiom considered a universal truth? Okay. Why the fifth axiom is considered as a universal truth? First remember that which one is the fifth axiom? So axiom 5 is that whole is always greater than its part. We know that this is the universal truth. This is a universal truth because part is included in the whole and therefore can never be greater than the whole in magnitude. So we can write one sentence in the answer of this question. This is a universal truth because part is included in the whole and therefore can never be greater than the whole in magnitude. Clear? In the answer of this question, you have to write this sentence. So these are the questions of exercise number 5.1. Okay, go through this video and try to solve in your FNB. Still you have doubt, you can ask me. Thank you.